Hi everyone, thanks for joining us with the PO.DAAC 101 series on how to use OPeNDAP to access data. Before we dive into the details, let's talk about some basic background on OPeNDAP. So what is OPeNDAP? First, OPeNDAP, Open Source Project for a Network Data Access Protocol, is a protocol for accessing distributed scientific data. Second, OPeNDAP is a generic data exchange mechanism that lies at the core of a variety of discipline data systems. Third, OPeNDAP is a software framework that simplifies all aspects of scientific data networking, allowing simple access to remote data. Fourth, OPeNDAP is a community of users and developers. What are the advantages of using OPeNDAP? First, share data over a network such as HTTP. Second, access and analyze remote data via IDL, MATLAB, Python, Ferret, GRADS, and any NetCDF application. Third, subsetting data on the server. Fourth, XML is the format for the persistent form of the data objects. Now let's go to the PO.DAAC website. From the Data Access tab, select OPeNDAP. We are now at the OPeNDAP page at PO.DAAC, and here is listed all the various parameters available at PO.DAAC. Next, we will select an ocean temperature file and drill down to the daily file of the Muir GRIST dataset. So here is a single daily file of the GRIST Muir dataset for January 1st, 2017. On the right-hand side, you can see the different response links for HTML, info, DAS, DDS, and DDX. Clicking on info shows the dataset metadata page, including global attributes and all the parameters in the data file. Let's go back to the previous page and explain what the different links mean. First, the DAS link. The DAS link, which means Dataset Attribute Structure, shows the variable and global metadata attribute info in JSON format. Click on it, and this page shows the DAS info in JSON format. Go back to the previous page and click the DDS link. DDS means Dataset Descriptor Structure. Now this page shows the variable type and array dimensions in JSON format. Next, select DDX. DDX is the combination of DAS and DDS metadata in XML format. Now this page shows the metadata in XML format. Click on the HTML link or NetCDF file. That will take you to the data access form. In the action bar, you can choose different data formats to download. You can also select which variables to download. Check time, longitude, latitude, and SST to download in NetCDF file format. Now that you have downloaded the data, it can be exploited by various third-party software such as Panoply. As you can see, all of the selected variables have been downloaded. A further verification is to create a plot of the analyzed SST. A key feature of the OPeNDAP is subsetting data. Going back to the OPeNDAP access page, we will subset SST over a small area of the Eastern Pacific Ocean. In the latitude and longitude variable index fields, for the SST variable, put a range of index values to subset to those indices. In the real application, you need to pre-calculate the indices for the region you want to subset. Click on Get as NetCDF4 link on the top of the page to download the subsetted data. Once the data are downloaded, you can verify the contents and that the data were subsetted. You can use Python scripts or other languages to access data via OPeNDAP and subset. Go to the PO.DAAC forum page, select Data Recipes from the categories, and then Data Access and Services. Here lists all the posts that are contributed by the PO.DAAC team and user community. Click on the Using Python to Subset Large Gridded Datasets recipe. The recipe provides a description, a link to download the Python script, and an example of how to run it. Finally, you can access the PO.DAAC OPeNDAP dataset directory from the dataset information pages. First, search for the MER dataset using the search field. Click on MER Level 4 dataset. And click on Data Access tab. There is a link that will take you directly to the MER OPeNDAP page. From there, you can select a daily file as shown previously. Thanks for watching the PO.DAAC 101 tutorial on OPeNDAP.